So this is our second lecture for sample size determination. In the previous lecture we have seen what is sample, why do we calculate a sample size, what are the disadvantages of having a large or a small sample. So now we are going to see how we calculate the sample size using either formulae or various softwares. Okay. So firstly we are going to see how do we calculate using formulas. So first is when we have proportion in our study as a parameter. Okay, so what is the formula we use when we have proportion or percentage in our study as a parameter, main parameter of our study? So this is the formula: n equals to z square into p into q by d square. Now here, what is z? The z square, this is the standard normal deviate. Then p is the proportion or prevalence. Q is 100 minus p, and d is clinically expected variation or precision, that is the allowable error. Now this allowable error, this can be either absolute or relative. Okay, absolute or relative. Now see, for example, we'll take an example to understand this. Example, the prevalence we get from a pilot study or from review of literature, it is 20%. So this will be our P. So absolute precision, if we take like only allowable error should be 5%. So this will be our D value in the formula. But if we say that it should be 10% in relative to the prevalence, okay, we say the error or this precision, allowable error, should be 10% in relative to prevalence. Then it is called what? Relative precision. Relative precision. So here what changes? The D value. So it is 10% of 20% prevalence. Okay, so 10 by 100 into 20%, what we get is 2%. So here the D value will be 2. Okay, so this is the formula for calculating the sample size when we have the proportion, okay, or percentage in our study as the main parameter. Now, important point, how do we find this prevalence? We will need the p-value for calculating. Absolute error we are deciding. Okay, so the prevalence we need to get from somewhere. So how do we calculate? हम कैसे पता लगाएंगे कि ये prevalence क्या होगी? This prevalence. Firstly, review of literature. I told you that you will be searching all the journals and the articles and find similar studies to find the percentage or the prevalence which is already present in a population for a specific thing that you are going to find in your study. So first thing is review of literature can tell us the prevalence. If review of literature is not your parameter for finding out this prevalence, then we do a pilot study. We don't get any prevalence from the review of literature. No such study has been conducted previously. What we do is a pilot study. We do a pilot study. And if this pilot study is also not feasible, what we do? We take 50% as the prevalence. This is the safest choice. Safest choice, the 50% prevalence we take. Okay. Now we'll find out this sample size by taking an example. Okay. We have a study in which proportion is the main parameter. Okay. The prevalence of anemia we are taking in this example. Okay. So question is, from a pilot study, एक पायलट स्टडी किया गया, उसमें it was reported that 28% had anemia. ओके, पायलट स्टडी में हमें पता चला कि 28% प्रेवलेंस है अनीमिया की, एंड इट वाज डिसाइडेड टू हैव 95% कॉन्फिडेंस इंटरवल. मतलब अगर हम 100 टाइम्स कोई स्टडी कंडक्ट करेंगे उसमें से 95% चांसेस होने चाहिए कि जो ट्रू वैल्यू है वो लाई करेगी बिटवीन टू स्टैंडर्ड डिविएशंस. दिस thing I have explained earlier in the part 1 of this lecture. Okay, then and 10% variability in the estimated 20%. ये क्या है? 10% variability in the estimated 28%, sorry, it's 28%. सो हमने कहा था हम एक प्रिसीजन लेते हैं, प्रिसीजन वैल्यू अलाउेबल एरर, तो हम कह रहे हैं 10% है. अब ये रिलेटिव है, ये एब्सोल्यूट है. अब यहाँ लिखा है 10% वेरिएबिलिटी इन द एस्टिमेटेड 20%. मतलब इन रिलेशन टू द प्रेवलेंस, इन रिलेशन टू दिस 28% should be 10%. So this is relative. Okay, relative precision. Now further the question is, how many patients are necessary to conduct the study. So we have to calculate the sample size. So now first thing, p-value, prevalence is given as 28%. So the Q will be 100 minus P, it will be 72%. Okay, 100 minus 28, it is 72%. Then we need the Z alpha. Now I've told you in the previous lecture that if we are taking it at 95% CI, the Z alpha value will be 1.96. D here is 10% of the 28% prevalence. So it is 10 by 100 into 28. So it will be 2.8%. So the sample size here will be Z square into P into Q by D square. Okay, so it is 1.96 whole square into 28 into 72 by 2.8 whole square. So the sample size here comes out to be 978.8, which will be taken, 987.8, which will be taken as 988. Now in your protocol submission, you will be submitting your protocol, you will be writing this formula. Along with that, you will have to write a statement. Okay, how to write it up? We'll write a sample size of 988 would be sufficient to observe 28% prevalence of anemia. Here we will write the reference study from where we have found this percentage, either the pilot study or the from the review of the literature. Okay, reference like X, Y, Z et al. Okay, with 10% relative precision and 95% confidence interval. Okay, so this was how we calculate the sample size when we have parameter as the main the main element for our study. Second, we have mean. When we have mean as a parameter of our study, so the formula here becomes n equals to z square into standard deviation square. Okay, this is the symbol for standard deviation, and then by d square. Okay, so instead of p into q, we have over here standard deviation. Then another category, when we have two groups, when two groups are involved, or we are testing a hypothesis, then how do we calculate the parameter? Again, we'll see when we have proportion and when we have this mean, how do we calculate the sample size. Okay, so for an analytic study, the formula will be different, and for a diagnostic study, the formula will be different. So analytic study, when proportion is the parameter, again we'll have p and q. Okay, so the formula over here will become n equals to z alpha plus z beta whole square into p into q into 2 by d square. Again over here, z alpha value, this is the z value for alpha level. Z beta value, this is the z value for beta level. Then we have p, the average percentage between the two groups, and q is 100 minus p, and this is the clinically meaningful difference between the two groups. Okay, so this z alpha is the z value for alpha level, z beta is the z value for beta level. Then we have the p, this is the average percentage between two groups. Then q is equal to 100 minus p, and d is the clinically meaningful difference between two groups. Then we come to the next one, when we have mean as the parameter. Again, we will have standard deviation instead of PQ. So the formula here becomes Z alpha plus Z beta whole square into this standard deviation square by d square. Okay. So over here, this standard deviation, this is common standard deviation between two groups. D is clinically meaningful difference again. Okay, clinically meaningful difference. Okay. Then we come to diagnostic studies. This was for the analytic studies. Now when we are dealing with diagnostic studies. Diagnostic studies. So now for diagnostic studies, when we are dealing with the screening tests, we are doing screening tests, then the formula is different, and when we are doing the confirmatory test, we are having a different formula, because in screening test we will be taking sensitivity, and for the confirmatory tests we will be taking the specificity. Okay, so firstly we'll see, when we have this screening tests, the true positive plus false negative equals to z square into sensitivity to 1 minus sensitivity by w square. So this will be giving us the sample size. This w is nothing but the d which we were using earlier in the formulas. Then we have specificity. False positive plus true negative equals to z square into specificity into 1 minus specificity by again w square. Okay, so these were the formulas for calculating different sample size. Now you must have seen that your seniors, when they have written a protocol, they have calculated a sample size. They have also sometimes adjusted or increased the sample size based on something. Okay, like the dropouts. Okay, based on the study designs. Okay, so we'll see when do we need the adjustment और when do we need to increase the sample. Okay, हमें कब adjustment करनी पड़ती है sample size में, या हमें कब increase करना पड़ता है sample size को. Example, एक follow-up study है. follow-up study है. अब ज़रूरी तो नहीं है सारे पेशेंट्स follow-up पे आए आपके. आपने RCT किया, follow-up पे पेशेंट्स आए नहीं, तो आपको जो इनिशियल सैम्पल साइज है वो थोड़ा सा बढ़ाना पड़ेगा, कंसीडरिंग द ड्रॉप आउट्स. जो लोग स्टडी को छोड़ देते हैं बीच में, उनको हम कहते हैं ड्रॉप आउट्स. सो फॉर फॉलो अप स्टडी, ड्रॉप आउट्स आर टू बी कंसीडर्ड. ड्रॉप आउट्स आर टू बी कंसीडर्ड. बेस्ड ऑन दैट वी इंक्रीज द सैम्पल साइज. ओके, अब अगर मेरी फॉलो अप स्टडी नहीं है बट मेरा रिस्पॉन्स बेस्ड स्टडी है, मुझे पार्टिसिपेंट से कुछ रिस्पॉन्सेस चाहिए हैं. ठीक है, कुछ मैंने एक सर्वे किया है. ठीक है, तो इसमें क्या चीज़ इम्पोर्टेंट होगी, नॉन रिस्पॉन्स रेट. इसके बेसिस पे हमें क्या करना पड़ेगा, सैम्पल साइज इंक्रीज़ करना पड़ेगा, क्योंकि कई ऐसे होंगे पार्टिसिपेंट्स जो कि हमारे क्वेश्चन को रिस्पॉन्ड नहीं करेंगे. सो वी विल हैव टू इंक्रीज द सैम्पल साइज. सो इनके लिए हमें क्या करना पड़ता है, जो भी हमारा सैम्पल साइज आया है, सैम्पल साइज जो फाइनल आएगा वो कैसा होगा, जो हमारा सैम्पल साइज आया है कैलकुलेटेड सैम्पल साइज बाय द रिस्पॉन्स रेट, ये हम डिवाइड करेंगे. ठीक है, इसके बेसिस पे जो भी हमारी वैल्यू आएगी दैट विल बी आवर न्यू सैम्पल साइज. ओके, देन एक और कंडीशन है, अगर हमारा क्लस्टर डिज़ाइन यूज़ हो रहे हैं, फॉर क्लस्टर डिज़ाइंस we inflate the sample size based on the design effect. If you want to understand this in detail, you can write in the comment box. Okay, so जब हमारा क्लस्टर डिज़ाइन यूज़ होता है तब हम क्या करते हैं, जो भी सैम्पल साइज आया है उसको डिज़ाइन इफ़ेक्ट से मल्टीप्लाई करते हैं. डिज़ाइन इफ़ेक्ट कैसे कैलकुलेट होता है, अब ये कैलकुलेट करने के लिए हमें क्या करना पड़ता है, 1 प्लस b माइनस 1 इंटू रो. अब ये क्या क्या है, ये b क्या है और ये रो क्या है. दिस b इज द क्लस्टर साइज and rho is the rate of homogeneity. This rho is having a minimum value of 0 and maximum value of 1. यूजुअली जो हमारा डिज़ाइन इफ़ेक्ट है, हम जो n इंटू डिज़ाइन इफ़ेक्ट करते हैं, ये यूजुअली हम 2 लेते हैं, ठीक है। ना अनदर थिंग, अब हमने सैम्पल साइज इंक्रीज करने का तो देखा, कैन वी रिड्यूस द सैम्पल साइज ऑल्सो। हमने सैम्पल साइज कैलकुलेट किया, बट हम चाहते हैं कि हम सैम्पल साइज को रिड्यूस करें। ऐसा किस केस में होता है? कैन वी रिड्यूस द सैम्पल साइज? यस। अगर हमारा पॉपुलेशन स्मॉल है, इफ पॉपुलेशन इज स्मॉल एंड well defined and well known, then sample size can be reduced slightly, okay, slightly, क्योंकि पॉपुलेशन साइज स्मॉल है, वो वेल डिफाइंड भी है, वेल नोन भी है, तो अगर हम सैम्पल साइज को थोड़ा सा रिड्यूस भी कर देंगे तो भी ज़्यादा डिफरेंस क्रिएट नहीं होगा। सो व्हाट वी डू फॉर दिस इज फाइनाइट पॉपुलेशन correction. What we do is finite population correction. So formula for this is n equals to n naught. This is the initial, n naught is the initial sample size that we had calculated, okay, by 1 plus n naught minus 1 by n. This capital N is the total population. So this is the formula for the finite population correction when we want to reduce the sample size. Okay, this will be the new sample size. Then we have seen all the formulae for the sample size calculation. Now we will see what software or website we can use. So we have this website www.openepi.com. This we can use, or we can use ClinCalc. Okay, this is software. So these we can use for the sample size calculation. So this was all about the sample size calculation. If you have any doubts, you can write in the comment box. Thank you.